Welcome to rktutorials, Solutions to Engineering Mechanics by S. Timoshenko, 5th edition. In this tutorial, we will discuss problem set 3.1, problem number 3.8. A crane ABC anchored in a cement foundation at A as shown in the figure. Two couples act on the crane as shown in the figure. Determine the resultant couple moment. That means there is a crane A, B, C is fixed at A. Now two couples P and P, Q and Q acting on this anchor as shown in the figure. The P makes an angle alpha, this P and this P both are makes an angle alpha with the vertical, and this Q and this Q makes an angle beta with the vertical. Our interest is to find the net resultant moment. Now, first let us try to find the net couple produced by this P and the couple produced by this Q. The couple, by the definition, the force P into the perpendicular distance. Now the force value is P, but this perpendicular distance is not known. I know only this distance. The distance between these two is known B, horizontal distance, but this B, this perpendicular distance is not known. So for that, what I will do, I will replace this P force into two components, horizontal and vertical. And I will also replace this force P into horizontal and vertical. So the horizontal component becomes P sin alpha, vertical component becomes P cos alpha. Similarly, this force P I will also replace with the two components. P sin alpha is the horizontal component, P cos alpha is the vertical component. Now this P sin alpha equal and opposite, hence these two gets cancelled. And this P cos alpha and this P cos alpha vertical forces, these two vertical forces are acting like this, hence it produces a moment in this like this. And also I know the distance between these two is P. So I can replace these two forces with a moment of force into distance, and the force is P cos alpha, distance is B, hence it is PB. Similarly, I can replace this Q into two components. Here this angle is given as beta, hence the vertical component Q cos beta, with horizontal is Q sin beta, and it is also Q cos beta, Q sin beta. These two are equal and opposite, and these two forces will introduce a moment in this direction, and the distance between these two is given as D. So I can replace these two forces with a couple moment with the magnitude of Q sin beta into D. So this is the given diagram. So this P I replaced with a moment of magnitude PB cos alpha. So these two P forces I replaced with PB cos alpha, and these two Q forces I replaced with QD sin beta. Now, if you take moments about any point, maybe A, B, any point for that matter, there are only two moments. This moment is acting in this direction, and this moment is acting in this direction. These two are equal and these two are opposite directions. Hence, the net moment is equal to QD sin beta minus PB cos alpha.